Test codes is basically a few lines of data that are given for a problem, and they're expressed in a very compact format. For instance, just to give you an example of that, in this case, we can see that the information that are known are divided into, say, state block, device block, etc. A comment line begins with the pound sign, and you can see that in the state block for state 1, the model, what model is being used, and what are the input variables, all are listed in a very systematic manner. And generating test code is very easy. You can store a solution. Once it is generated, you can store it in your own computer. And you can use it to jumpstart a solution or wherever you left it off last time. And you can modify test code for parametric study and several other things. For collaboration with others, you can just pass a test code forward or understand the algorithm of the problem, of how somebody solved a problem using test codes. And there are plenty of examples of test code all over test. So I'll quickly show how we already solved a problem in another video where we had a state 1 calculated, state 2 calculated, and we loaded the device. We loaded the state 1 and 2 at the inlet and exit state. It was a compressor problem really. State 1 was the inlet state obtained from pressure and temperature, mass flow rate was given. And state 2 is an isentropic exit state. Pressure is given and entropy is equal, expressed through a simple equation. So it's a very simple problem. But notice, so the answer here is that the work required by this compressor is minus 280 or 280 kilowatt really. So now look what happens if I click the super calculate button. It switches you over to the I/O panel, and as you can see, this is what the test code looks like. First, it does tell you the app that was used in this case. So you can match it. You will find that this is exactly the app that has been used. And then it lists the information. States block tells you what is known about state 1, what is known about state 2, and finally in the device block it tells you state, what are the given information plus single flow device, and 1 to 2 cryptically represents that 1 is the inlet and 2 is the exit. So it's difficult to write test code from scratch, but it's very easy to copy and paste it somewhere and regenerate a solution. So for example, suppose let's go to a complex problem and see if we can regenerate the solution. So we'll pick a very complex gas turbine problem with tons of states. So suppose, look at this problem. There are something like 11 states to compute in this problem. And obviously, if we can regenerate the solution, it's much easier to simplify a problem like this. Again, we are already on this path, as you can see. So this is our test step. So all we do is copy the entire code, Control A and Control C, go to the HTML5 page. We come back to the I/O panel. Essentially, we are doing the reverse thing now. We paste the code here and just click the load button and wait for the answer to appear. Look, you'll find that all the states are populated, just like in the original solution. The graphics panel shows all the states calculated, all the devices are already populated, and the cycle panel, you can see all the results. So in a nutshell, once you have the test code, it's very easy to regenerate the solution and then maybe change a parameter or two and see how it affects by just changing a parameter and then clicking the super calculate button, regenerates the solution, it updates the solution for every panel. And coupled with user code, test code becomes a very potent programming tool, which I'll discuss next.